Okay, so this is the third and the final video in this series. All right, what I've tried to do is just show you a variety of different things. Most of this is just kind of calculus review for you, things that you've done before. Maybe not exactly like this, but the basic ideas should be pretty familiar to you. All right, so in this one, we are looking for a centroid. Now, it just says Y, it doesn't say X or Z, but you can see that the thing is symmetric around Y. So the Z centroid and the X centroid are actually on the Y axis. Okay, so we can call that argument by symmetry. Say that the X and Z centroids are on the Y axis. Okay, so what we got to do is figure out, so where the heck is that centroid going to be? Okay, so it's going to be out here somewhere, and we'll end up doing the same approach, which is to say Y. Boy, that's super tiny. Let me fix that up a little bit. Y is going to be a moment term, all right, divided by a total term, in this case, the volume. Okay, so first thing we want to do is to get a volume, and we're just going to use, instead of using a Calc 3 thing, I mean, we could do cylindrical coordinates and say we've got an r dr d theta dy kind of a situation, but let's not do that. Let's just come through here and slice this thing up into a bunch of disks. Okay, just like this. Boop, 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 boop. And each one of those disks has an area A, okay, and a thickness dy. And so that becomes our volume element right there. And there's a certain radius that goes with that. Okay. Now, that radius value is just going to happen to be whatever z is at the time. So here it says z squared is 1/4 y. And so really that's the same thing as r. In our case, z is equal to r. So that means this 1/4 y is actually r squared as well. Okay, so let's go ahead and work it out. Let me give myself a little bit more room here. And so our volume is going to be a bunch of volume elements. Okay, so we're going to go A dy, and we're going to be going from 0 to 1. Just like so. Okay, now our area is going to be pi r squared. So we're going to put pi r squared dy. And the r is actually this 1/4 y term that we talked about there. So I want to put that in there as well. Okay, so we're going to have here that we've got, put my pi outside. My r squared becomes the 1/4 y, and then I still have my dy. Okay, so for r squared, we're going to that thing right there. And our limits are still from 0 to 1. Okay, so we've got pi over 4. Y becomes 1/2 y squared, 0 to 1. And so that whole thing then becomes pi over 8. Okay, just like so. Boom. Okay. All right. Now, there you go. So we're gonna need that. Here is what we're gonna end up putting in up there. So what we need now is the y element, or the y moment, I should say. Okay, and so our y moment is just, so sloppy, just y dv. All right, so that's going to get us to, it'd be a dy, but a is pi r squared. Okay, so I'm going to have pi r squared y dy. Okay, so my dv turned into pi r squared dy, just like we saw over here on this side. Okay. And our limits are still from 0 to 1, like so. And my r squared is still 1/4. All right, so I still got pi 0 to 1. R squared is 1/4 of y. Then I've got my y dy. Okay, so again, the r squared becomes that term right in there. Okay, simplify that up. I got pi over 4 out front, 0 to 1, y squared dy. That becomes pi over 4, y cubed. I need a third term on there, like so, 0 to 1. So what we end up with is pi over 12. How about that? Woo! Okay. And then this is what we're going to use up here. Okay, so we come along here. We've got pi over 12 divided by pi over 8. Okay, the pi's are going to go away. The 8 comes up on top. I got 8 over 12, which becomes 2/3, like so. Yeah, 2/3. 8 over 12 divided by 4. Blah, blah, blah. Yeah, I like it. Okay, there we go. Just like that, all right? So, again, I've said it several times at this point. We're just basically using some calculus techniques that you've seen many times before. Okay. Yeah, you could do this on your calculator. All right. But it's not like these are complicated. To be real honest, guys, if you have to do polynomials, okay, don't get that lazy. Okay, don't get that lazy. You're gonna shoot yourself in the foot. Okay, save your calculator for when you got something really nasty that you need to do. Okay, you might get something symbolic, in which case maybe your calculator could do it, maybe it couldn't. But anyway, there you go. That's the last one of these. So good luck on your homework there.